Okay, can you turn it down a little bit more? How are you guys? Thank you, Avery. Just got it. All righty. So, oh, here comes whatever. All righty. So today we're going to continue talking with our perimeter and area of figures. And I know y'all had homework from your packet. If you already uploaded it, that's great. If not, you can go ahead and upload it a part at a time, or if you would rather go ahead and we can turn it in all at one time together. That's going to be totally up to you. So if you want to wait and turn it all in at one time as one packet when it's completed, you can do that, or you can do it all at this, you can do it day by day. So if you haven't uploaded it, it's just fine. We can wait. It's not a big deal. The main thing that I would like you to do though is that, you know, whatever your homework is, I would like it to be completed by the next class, so you can make sure to ask questions if you have any, and so that way you're not lost when we move on, okay? Because if you haven't done your homework and we move on, you might get lost, okay? So, all right, so let's see, let me go ahead and share my screen and then we'll get going. We'll check our homework. And then let's see. I'll make sure I have. Make sure I've got my page so I don't see Noah yet. So hopefully he'll log in. Okay, so let's go ahead and take a look at our part 2 of page 141. If you don't have those out, go ahead and get them out. Now, remember we talked about how notice that we ended up having to deal with a square root in one of our problems. One of the things that I want you, we'll kind of talk more about those today, because we are going to end up working some with square roots and having some square root answers and square roots in our problems. And we'll kind of do a little refresher about that in just a minute after we've checked our homework. So again, this is, let's see, worksheet 42. Let me get to the right page. Alrighty. So I'm going to go ahead and just fill in the answers on here so you can check your answers. If you missed something, I want you to be sure to correct it. If you have any questions, also, we will go over it. So we've got, whoop, I need to get my, alrighty. So our first one, we talked about, we are having squares. We talked about how our formula for the perimeter of a square is we just multiply 4 times the measure of one side. And 4 times 8 is 32. And we know that we are dealing with centimeters, so 32 centimeters. For area, we said it's going to be side squared, so 8 squared is 64. And in this one, we would have centimeters squared. Any questions on that one? Okay, our next one, we had already solved that we had 7 feet. And we kind of walked through that when we said, hey, if I've got area and area is side squared, that means I have a number squared equals 49. Well, we already talked about that 7 squared is 49. So we know that each side is 7 feet. So now we do 4 times 7 is 28 feet. And they had already told us the area. All right, so now we've got to think about the next one. My perimeter is equal to 6. So in this situation, what I do is I say, okay, 4 times a side equals 6. So that means I have to divide both sides by 4. So each side is equal to 1 and 2/4. And we know that 1 and 2/4 is equal to 1 1/2. So we could either have that as a fraction or we can put that as a decimal. So we know that each side is going to be 1 1/2 inches or 1.5 inches. Okay, so now that we know the measure of each side, when we go to area, that's going to be side squared. So that's going to be 1.5 squared, and 1.5 squared is going to equal 2.25 inches squared. Any questions on that one? All righty. Okay, and then we did this other one where we said, hey, I'm going to have to take the square root of 10.89 kilometers squared. And we found that the square root of that was about 3.3 kilometers. So now we got 3.3 times 4. And when I multiply 4 times 3.3, that is going to be 13.2 kilometers. Any questions on that one? Okay, the next one, my perimeter is 14. So again, I have the formula where 4 times each side equals 14. Divide by 4, divide by 4, and 14 divided by 4 is going to equal 3 1/2, and we can put that as 3.5. So we know each side is 3.5 meters. Or like I said, you could have 3 1/2 using a fraction. Either way. Okay, so then we've got to go find the area of that. So 3.5 squared. Or if you kept it as a fraction, you could say 3 1/2 times 3 1/2, either way, okay? But when you multiply 3 1/2 times 3 1/2, that's going to give you 12 1/4 or 12.25 meters squared. Now remember, when I multiply fractions, this will be the same as saying 7/2 times 7/2. That'll be 14. That doesn't work. 6, 7/2, 7/2. What did I do wrong? 3 times 2 is 6, plus 1 is 7. So that's 7/2 times 7/2. Oh, I said 7 times 7 is 14. Y'all didn't. That's 7 plus 7. All right, 7 times 7 is 49. I was going, something's not right here. So that's 49/4. And so we know that 4 will go into 49 12 times, and then I have 1 left over. So I can either have 12 1/4 or 12.25 meters squared. Any questions on that one? And then my last one, they gave me my side, 2 1/4 yards. So when I add 2 1/4, or when I multiply that times 4, or I could add 2 1/4, 2 1/4, 2 1/4, 2 1/4. When I add those together or multiply by 4, 9 yards. But when I do 2 1/4 or 2.25 squared. Again, that's going to be like 2 1/4 times 2 1/4 if you worked with it as a fraction. 2 1/4 squared is going to end up being, so if I use my calculator, 2.25, oh, hang on a second, let me see. No, I can't find the Zoom link, hang on. Okay. Give him a minute to log in and catch up. Okay, so like I said, if you wanted to work with your decimals, 2.25 squared is going to equal 5.0625. Or if we worked with, if we worked with our fractions, I go to an improper fraction, and 4 times 2 is 8, plus 1 is 9. So I have 9/4 times 9/4. 9 times 9 is 81. 4 times 4 is 16. 81 divided by 16, it'll go 5 times, but then I have 1 left over 16. So basically, we can see here that 1/16, well, is equal to 0.0625. That is 1/16 as a decimal. So you can either have it as a fraction or a decimal. Get Noah in. All right, hey there, Noah. We were just checking over our homework. So if you'll just go ahead and get out your worksheet and check your answers, what I'll do is I'll kind of look at the first one. They gave us 8 centimeters. When I multiply that by 4, I get 32 centimeters. When I square it, why did I write 62? That's supposed to be 64. I don't know what I'm doing, y'all. Glad we went over that. So check your work. Remember, 8 times 8 is 64, so 8 squared is 64. If y'all see me make a mistake, y'all gotta tell me. Okay, and then the next one, we had already figured out that it was 7 feet. So when I multiply 7 times 4, that's 28 feet. And we already had the area. The next one, they gave us 6 inches. So if I know that each side is an equivalent amount and they add together to make 6, 6 divided by 4 is going to give me 1.5 or 1.5. So that's going to be the measure of each side. Is either, you can either write it as a fraction or a decimal. But then to find the area, I had to multiply it by itself. And I end up with 2.25 inches squared. Or we could have 2 1/4 inches squared. You can have it either as a fraction or a decimal. Then we found that when we have 10.89 kilometers squared, we had to take the square root of that. And we found that that was approximately 3.3 kilometers. When I multiplied that by 4, I got 13.2 kilometers. And then the last one, 2 1/4 yards. We could either work with that as a fraction or as a decimal. As a fraction, we said it would end up being 9/4 times 9/4. So that would be 81/16, which reduces to 5 1/16. If you chose to work with it as a decimal, 2.25 squared is 5.0625. And that is, let's see, our measurement on that one was yards, so that'd be yards squared. Okay, so we could either have 5 1/16 yards squared or 5.0625. The main thing to remember is any four-sided figure, to find the perimeter, I add the 4 together. To find the area, I multiply the length and width. Now with a square, it just so happens that all of my sides are the same measures. So I can take my measure and multiply by 4 to get my sides, or I can just add side plus side plus side plus side. Same thing with finding the area. I'm just going to multiply side times side, and that's the same as side squared. Okay, so I'm doing the same things. I just have some little different formulas that I can use. I don't have to do it. I can follow the same formulas that I use for a rectangle. I'm going to get the same answers. Okay, so any questions on that? Okay, and that was all of our homework, correct? We just had that little part. Okay, awesome. So now I'm going to go back to my notes from the textbook, and we are going to start, I believe, with triangles, lesson 84. I forgot to mark these out. Hang on a second and I'll get. Okay. All right, so we are starting with lesson 84 on our little notes. Okay, so we're starting with triangles. And it says a triangle is a polygon having exactly 3 sides. So a triangle is a 3-sided polygon. Or you can just write a triangle is a polygon that has 3 sides, that has exactly 3 sides. Whatever you want to say, you just need to put polygon with 3 sides. And it says to find the perimeter of a triangle, find the sum of the lengths of the 3 sides. So underneath your definition, it says write the formula for the perimeter of a triangle. So the perimeter is going to be right here, where it's A plus B plus C. So my formula for perimeter of a triangle is A plus B plus C, where A, B, and C are the 3 side measures. Okay, so I've got 3 sides, I add them together. That's how I find the perimeter of a triangle. Now notice underneath it, it says to find the area of a triangle, find half the product of the base and the height. So my formula for the area of a triangle is area equals 1/2 base times height. 1/2 base times height, where B is the base and H is the height. So 1/2 BH. All right, so I want you to see something for a minute. Let's see if I can. It's a little thick. Let me get it skinnier. Whoop. Notice if I were to do this, basically I could turn my triangle, I can connect another side, and I would have a rectangle there. The only reason I know it's a rectangle is because one side is 4 and one side is 3. So I can tell that these are a little bit, that it's not quite the same measures. Okay. But notice a triangle is basically either half of a square or half of a rectangle. So when I look at this, that's the reason my formula is 1/2 base times height, because a rectangle is area equals base times height. If a triangle is half of a rectangle, then that's why my formula is 1/2 base times height. So when I'm looking at that, I know that my base is going to be here. My height is here. Okay. Now, one of the things that I want to be careful of is remembering that multiplication is commutative. And so there may be some times that I say, if I said, I've got a base of 3 and a height of 4, well, it would be like if I turned it. So remembering that, the shapes can be turned. So whenever I have a right triangle, and this is a right triangle, and I can tell because of that right there, my right angle tells me I'm dealing with a right triangle. So with a right triangle, my base and height are the legs of the triangle. Okay, so my base and height are the legs of the triangle. Does anybody remember what this side of my triangle, of a right triangle, is called? This side of a right triangle is called a hypotenuse. And these are called the legs. So that's when I'm dealing with a right triangle. I have 2 legs and a hypotenuse. The hypotenuse is always the side that is opposite the right angle. Okay, this is not necessarily stuff that you have to know right this minute. It is stuff that you'll see again when we get in Algebra 1, and then especially in geometry when you start learning about shapes. But in this situation, I just wanted you to know the difference between this triangle and maybe another one that we see in just a minute. Okay, so they said this figure is a triangle. The perimeter is 3 plus 4 plus 5. Remember, they said I just add side plus side plus side. So it doesn't matter which side I call A and which one I call B and which one I call C. It really doesn't matter because, again, addition is commutative. If I add 3 plus 5 plus 4, that's the same as adding 3 plus 4 plus 5, which is the same as adding 4 plus 3 plus 5, which is the same as adding 5 plus 4 plus 3, okay? Doesn't matter what order I add them in. The fact is I just add my 3 sides together. So my perimeter is 12 units. Now, to find my area, we said I have base times height. So I have 1/2 times 3 times 4. Now, sometimes it just depends on what these two numbers are. Sometimes it's easier just to go ahead and multiply these together and then take half of that. So in this situation, 3 times 4 is 12. Half of 12 is 6. Or you could say half of 4 is 2, and 2 times 3 is 6. Again, it's commutative, so it doesn't matter what you do. So you can either take half of a number and then multiply it by the other, or you can multiply your two numbers together and then multiply them by half. Remember, multiplying by 1/2 is the same as dividing by 2, okay? So if I multiply 3 times 4 and then I multiply by 1/2, that's the same as saying 3 times 4 divided by 2. So multiplying by 1/2 is the same as dividing by 2. Okay, so let's go ahead and take a look at our picture over here. All right. Now, one of the things I want you to know is they have put this extra little line in here for us. Sometimes you may see a triangle and they will have a dotted line like this. And I guess actually we'll see it in the one at the bottom of the page right here. But notice that this triangle in particular is not a right triangle, but they put this line right here. It's called an altitude. They put that in there to show me the height of my triangle. But if I have a right triangle, I already have the height given, and that's going to be right here. Okay, so really in this problem, this is extra information. The 60/13 is not needed information. That's extra information. Okay, so it says list everything you know to be true about the diagram below. Well, first of all, we know it's a triangle, right? Which is a type of polygon. And what do we know about the perimeter? perimeter equals A plus B plus C. So if I pick and I say A, B, C, I'm going to have 5 plus 13 plus 12. When I add those together, 5 plus 13 is 18, and 18 plus 12 is 30. Now remember, if it does not tell us a specific unit of measurement, I just call it units. So my perimeter is 30 units. My area equals 1/2 base times height. In this situation, my base is 12, my height is 5. So I'm going to have, this doesn't show up as well on the dark part. Let me change my pen color real quick. Come on. Okay. So area equals 1/2 base times height. So now, oh, hold on a second. Let me rewrite those real quick. Sorry. And actually, I think I might make it red. I think that'll stand out more. Okay, sorry. We just said that B is equal to 12 and H is equal to 5. So when I do 1/2 BH, I've got 1/2 times 12 times 5. Now, I can either multiply 12 times 5 and divide by 2, or I can take half of 12 and then multiply that by 5. And so half of 12 is 6, so 6 times 5 is 30. And again, we'll call that 30 units squared. Okay? It does not matter what I multiply together first. I can multiply 1/2 and 12 and then multiply by 5. I can say 12 times 5 is 60, and 60 times 1/2 is 30. I'm going to get the same answer. Any questions about that? Any questions about either area or perimeter of a triangle? Okay. Let's move on down to activity 2. Like I said, sometimes when I'm dealing with a triangle that does not have a height, we use this mark called an altitude to be able to show the height of the triangle. So anytime an altitude is drawn, it goes from my furthermost vertex, and it intersects the opposite base at a 90-degree angle. So that's why you can see that they've put that little mark there, and it's a dotted line. So in this situation, I know that this is going to be my height. Okay? So I know that when I talk about my base, this is going to be my base right here. It's going to be 2 plus 4, which is 6. So my actual base is going to be 6. My height is 3. Okay? But now we've got to look at this and all right. So what we're going to do is we've got our chart to tell us something. But I have a note here that says refer back to lesson 18 on page 39. Let's do that for just a minute. Let's flip back to page 39 in your workbook. And let's think about square roots for a minute. Okay? Remember my rules for square roots. My first one is I can add or subtract radicals if they are the same index and radicand. So my example of that would be 3 times the square root of 2 plus the square root of 2. Remember, that's the same as 3 times the square root of 2 plus 1 times the square root of 2. So that would equal 4 times the square root of 2. I add the numbers before the radical and keep the radical the same. Same thing with subtraction, as long as my radicals are exactly the same. That means my index is the same. Remember, my index is the little number that goes right there. If there's not a number there, I understand that it says 2 for square root. Okay, so as long as those two are the same, I just add my coefficients or those numbers in front. Now, to multiply, radicals, you multiply the coefficients together. Those are the numbers outside. Multiply coefficients. And radicands. So the example of that would be if I had 3 times the square root of 2 times 2 times the square root of 2. In that situation, I multiply 3 times 2 on the outside, and on the inside, I put 2 times 2 because I have 2's under my radicals. 3 and 2 are outside the radical, 2 and 2 are inside the radical. So then I have 6 times the square root of 4. Now this leads me to where I have to simplify radicals, okay? So remember, if I know the perfect square, and I know the square root of 4 is 2. So I'm going to have to multiply 6 times 2, and that is 12. Okay? So simplifying radicals is where if I had the square root of 12, remember, this is where I break it into prime factors. I say my prime factors of 12, my smallest prime factor is 2, and that's 2 times 6. My smallest prime factor of 6 is 2, and that's 2 times 3. So I can check this, and 2 times 2 is 4, 4 times 3 is 12. So I've broken 12 into prime factors. Because it's a square root, I circle my 2 buddies. My 2 buddies are able to come out, but that 3 stays under the radical. So that is simplifying radicals. So anytime I have a radical answer, I need to make sure to simplify it. Okay, so that's our quick brush up on dealing with radicals. Now, when I look at this one, I can see that they have said that one of my sides is the square root of 13. So we can go back to page 185 now. Let's go back to page 185. Okay. Now notice they said, hey, we're going to be looking at 3 separate triangles here. So let's break those apart for a minute and let's look at what they're wanting us to see. I can get that 6 to erase without getting the whole thing to go away. Nope. Okay. There we go. Okay, so basically I have 3 triangles in this figure. I can look and I can see that this is going to be, so the first one they want us to look at is triangle ABD. Triangle ABD is going to be ABD. So this is one triangle here. Okay, so when I'm answering questions first, it's going to be for triangle ABD. We're going to find the perimeter and the area of that triangle. The next one is triangle BDC. So let me get a different color. We'll make it purple. BDC is going to be this one right here. So again, we'll find the perimeter and area of that triangle. And then finally, the entire triangle ABC. So that will be looking at triangle A, B, C. So we're going to be breaking this apart into 3 separate triangles and looking at those. Okay, and actually let me make that a little bit darker. Let's see if this will make it darker so we can put it. That'll be the 3rd one we're looking at. So we can focus on the green, the purple, or the pinkish red as my whole triangle. Okay, so let's start with triangle ABD. If I start with ABD, I can see that I've got the square root of 13 is one of my sides. Another side is 3, and another side is 2. So that means I have P equals the square root of 13 plus 3 plus 2. Now remember, when I have a radical, I can only add it together with other radicals that are exactly the same. So there's nothing I can really do with my radical, but I can combine 3 plus 2. And 3 plus 2 is 5. And then I'm just going to leave this as 5 plus the square root of 13. And I'll go ahead and put units. So I'm going to have to leave my answer like that. I'm going to have to keep 5 and the square root of 13 separated with a plus sign because I'm adding them together. I cannot combine them together because they're not like terms. Does everybody remember that? It's been a while since we worked on radicals, but we have to keep, they're going to keep trying to integrate it. Sorry, hang on. All right, so let's look at our next part. We're doing area. So remember, area is 1/2 base times height. And actually, if you want to go ahead and put here in perimeter, perimeter equals A plus B plus C. You can write that formula there. And then for area, capital A equals, excuse me, 1/2 base times height. Okay. So we're going to be using 1/2 base times height. So I'm going to go back to that triangle. And my base of this triangle is going to be right here. So that's going to be 2. And my height is 3. Okay, so I'm going to have 2 times 3. I think the FedEx man is about to knock on my door and the dog will go nuts. Hang on. Sorry. Okay, so y'all can see I went ahead and put area equals 1/2 base times height. Our base was 2, the height was 3. So 1/2 times 2 times 3. 2 times 3 is 6. Half of that is 3. So we'll put 3 units squared. Any questions? All right, next we're going to focus on triangle BDC. We see that BDC is going to be our purple triangle. So BDC. So again, I've got this side here that's 3, this side that's 5, this side that's 4. Okay, so for perimeter equals 3 plus 4 plus 5. 3 plus 4 is 7. 7 plus 5 is 12. So that will be 12 units. Y'all good? And then the next one, area is going to equal. Now let's look back. Base times height. Our base is going to be down here. Our base is what intersects with our height. So we have 4 times 3. So for my formula, I'm going to have 1/2 times 4 times 3. So again, you can take 4 times 3 is 12 and divide that by 2. Take half of 12, which is 6. Or you could say half of 4 is 2 and 2 times 3 is 6. It doesn't matter. Either way, it's going to be the same answer. So 6 units squared. Actually, I think I'm going to turn my screen so it'll give us a little bit wider view. There we go. All right, now our next one is triangle ABC. So that's going to be taking the entire triangle into account. So I'm going to erase everything over here so we can see it all just as one triangle. All right, so now when we're talking about the triangle as a whole, ABC, we still have this side as the square root of 13. This side is 5, but this side we have to add 2 and 4 to make 6. So when I find my perimeter equals, we still have the square root of 13, but now we have the square root of 13 plus 5 plus 6. Okay, so now we have the square root of 13 plus 11. Or you could write that, and if you want your number first, plus the square root of 13. Again, it doesn't really matter. Same thing. Okay, so look back. We know for area, we're going to do base times height. So in this one, our base is still going to be 6. So our base is 6. Our height is 3. So we're going to have area equals 1/2 times 6 times 3. You can either say 6 times 3 is 18 and multiply that by 1/2 or divide by 2, or say half of 6 is 3 and 3 times 3 is 9. Either way, you're going to get 9 units squared. I forgot my units on this one. Okay. The main thing to review, the main thing that we had right here with our radical is we just cannot combine it with our whole numbers, because to be able to combine it, my other number has to have that radical. Okay. All righty, let's go ahead and turn the page. We have got another one where we've got 2 triangles put together to make a quadrilateral. And we can see, looking at this quadrilateral, it is actually a parallelogram. Okay. So one of the things that we talked about the other day when we talked about parallelograms, we said that parallelograms have 2 pairs of parallel sides. So when I talk about my parallel sides, I know that this side is parallel to this side. And they're also going to be congruent, which means their measures are the same. So notice that my top one is 5. My bottom one is also 5, but I'm having to add these 2 together because they've said that, hey, this part is 1, this part is 4. So when I add them together, that side is 5 as well. And we also talked about how not only are those congruent and parallel, then these sides are parallel and they are also congruent. So I went ahead and wrote over here that since this one is the square root of 5, I know this side is the square root of 5. Okay, so this side is 5, this side is 5, but then my other sides are the square root of 5. It also tells me that all of my measurements are given in centimeters, so I know my measurement here. Okay. So now I've got to pay attention. Notice here the figures. The first one says I'm looking at parallelogram JKLM. Then I'm going to look at triangle JLM and then triangle JLN. Okay. So those little signs and those little symbols in front of the letters tell me what I need to focus on for each problem. All right. So the first one, I'm doing the perimeter of parallelogram JKLM. So how many sides does a parallelogram have? 4. So I know for my perimeter, I'm going to be adding 4 numbers together, or I can say 2 times the length plus 2 times the width. But when I look at my sides, I have the square root of 5 and 5 are my 2 sides, and I have 2 of each of them. So I can either say that the perimeter is equal to the square root of 5 plus the square root of 5 plus 5, which is the same as saying 2 times the square root of 5 plus 2 times 5. Okay. Now, remember a minute ago when I talked about that if I have the square root of 5 plus the square root of 5, I want you to think about that. The square root of 5 plus the square root of 5. Remember, like variables, if I don't have a number in front of it, I remember that that's actually a 1 in front of it. So if I'm adding the square root of 5 plus the square root of 5, 1 plus 1 is 2, and I keep my radical the same. So that's going to be 2 times the square root of 5. Well, right here, when I multiply 2 times the square root of 5, I'm getting the same thing. So 2 times the square root of 5 plus, and 2 times 5 is 10. Again, I have to keep these apart by a plus sign because these are 2 unlike terms. I cannot put 10 with 2 times the square root of 5 because 10 does not have a square root of 5 with it. Okay. We'll go ahead and do the area for this problem, and then we'll take a break. Okay. So remember my formula for area. So I'll go ahead and put perimeter equals, we'll write, sum of sides. Now on this one, our area equals base times height. So again, when I look at a parallelogram, my base is going to be this side right here. And we said that that is 5. My height is going to be right here, this dotted line. So right here, 2 is equal to my height. So my base is 5, my height is 2. So my area is equal to 5 times 2. And we said these are centimeters, remember? So area equals 10 centimeters squared. Base times height.
Well,
all right, let's get ready and take.
One half base times height. It's 1/2.
Well, this one, remember, this is a parallelogram. So triangles are 1/2 base times height.
Okay.
Yeah. So in just a minute, when we deal with our triangles, they will be 1/2 base times height. Okay. Go ahead and take a 5-minute break, and we will come back. Okie doke, let's get ready and come on back and we will finish up the perimeter and area of the triangles included in our figure. Okay, so here we've got, we've already looked at our figure as a parallelogram. So now we are going to break it into triangles. Okay, so the first one we're looking at is JLM. So let's see. All right, JLM. Remember, one of the things about naming figures is I can always figure out exactly where I'm going if I just follow the letters in order. So I'm going ahead and draw in a letter from J to L. Now I'm going from L to M. Okay, so now I can see that this is the triangle I'm talking about. JLM. So immediately I can go ahead and identify my sides, my base, and my height. So I can see that I've got one side is the square root of 5. Another side is 2 times the square root of 5. And then this other side was 5. Okay, so for the perimeter, we're going to add the square root of 5 plus 2 times the square root of 5 plus 5. So remember, we talked about how the square root of 5 plus the square root of 5 is the same as saying 1 times the square root of 5 plus 2 times the square root of 5, and 1 plus 2 is 3. So we have 3 times the square root of 5 plus 5. And that's going to be our final answer because I cannot combine them since they are different units. So I have 3 times the square root of 5 plus 5 centimeters is my perimeter. Okay. Now let's look back, and we're looking at base times height. So we know our base is right down here. We said our height is going to be from the vertex to the base, and that is the number 2. So my area is equal to 1/2 base times height. So I'm going to have 1/2. My base was 5. My height is 2. So 1/2 of 5 times 2. 5 times 2 is 10. Half of that is 5. That'll be 5 centimeters squared. Any questions on how we did that one for perimeter and area of our first triangle? Okay, let's look at JLN. So again, I want to trace to make sure I'm talking about the right one, and it says, let me erase this. Okay, so now it said I need to do JLN. So I go from J to L and then L to N. So notice that I stopped there at N. So JLM, I had to go all the way to M, but this time I'm focusing on just JLN. So on this one, when I look at my sides, I can see now that I'm talking about a side of 2. I have a side of 2 times the square root of 5 and a side of 4. Okay. And then again, my base is going to be 4, and now my height is 2. Okay, so let's go ahead and plug into our formulas. So for perimeter, P equals 2 plus 2 times the square root of 5 plus 4. Combine my like terms of 2 and 4. 2 plus 4 is 6. but then I have to leave 2 times the square root of 5 on its own. So my perimeter is 6 plus 2 times the square root of 5 centimeters. And then finally for area equals base times height. One of the things that I like to do is go ahead and write the formula because it helps me to remember exactly what I'm supposed to do. And then that way I don't forget to plug something in. And especially when I'm doing the area of a triangle, I don't forget to multiply it by 1/2. So we said the base here is 4 and my height is 2. So I have 1/2 times 4 times 2. 4 times 2 is 8, and half of that is 4. So I have 4 centimeters squared. All right. Everybody good about that? All right, we'll go ahead and take a look at our figure down here. Notice it says in the game at the left, all of the boxes with the same color have the same dimensions. All measurements are given in inches. Use this diagram to answer the following questions. So notice we've got the blue boxes. And so they've told us that this side of the blue box is 2 and this one is 2. So that means this side is 2 and this side is 2. So all of my blue boxes are squares and they all have sides of 2. Now they've told me that my other smaller box, this side is 1. So that means this side is also 1, but then this side is 2 and this side is 2. Okay, so we've got squares and rectangles here. So it says, what is the area of one blue box? So remember, my blue box is going to be side squared, or side times side, and 2 times 2 is 4 inches squared. The area of a white box, I multiply 1 times 2. 1 times 2 is 2 inches squared. So now it says, what is the area of the entire game? What I've got to do is I know that this side is 2, this one is 2, and this one is 2. So my whole entire side is 6 across the bottom here. I've got 2 and 1 is 3. 3 and 2 is 5. 5 and 1 again is 6. So my area is going to be 6 times 6, which is 36 inches squared. Okay. Now they're asking us a probability question. It says if a penny is randomly tossed into the game box, what is the probability that it will land in an area that is white? So remember, when I'm doing probability, the first thing I've got to do is I've got to look at how many total possible options I have. Okay. And so think about if one of these, if one of my white boxes counts as 2 of my blue boxes, right? So I have twice as much chance of it landing on blue than I do white. But if I had to break up my blue boxes into equal segments, I can see now that I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 there. Okay. So I guess basically you could break it down. So if you looked at the total area, you could either say 6 times 2 is 12 and 12 out of 36, or in this situation, the way I've broken it down, we can see for white, I've got 1, 2, 3, 4, 5, 6 chances out of 18. And 6 out of 18 is the same as 12 out of 36 because that reduces to be 1/3 and that reduces to be 1/3. So either way, you have a 1/3 chance of it landing on white versus blue. Okay. Hang on just a minute. All right, sorry. Someone coming in the front door, dog goes nuts. Okay, so on this one, it says, what is the probability that the penny will land in a blue area in the center row? So now what I've got to do is I've got to focus on my center row here. Erase this. Okay, so when I'm looking at my center row, I'm talking about that right there. So remember, if I break these into pieces, I've got 1, 2, 3, 4, 5, 6. So I have 6 total possible. And out of those, 1, 2, 3, 4 are the blue in the center row. So 4 out of 6, which is going to reduce to 2/3. Okay. Let's see. What did I do differently there? I think what I did before is if I said the area of this, so like the area of this is going to be 4. This is 4. So that's 8. And then, well, I think what I did is instead I took 8, I did 36 there, and it should have been out of, that would be what, 2 and 2. So it actually should have been 8, 9, 10, 11, 12. So it should have been 8 out of 12, which is the same as 4 out of 6. So that's a mistake that I've got right there. All righty. So when I look at my area of my blue, I've got 2 times 2 is 4, 2 times 2 is 4. So my area of blue is going to be 8. My area of white is going to be 2 and 2 is 4. And so that's why I end up having 8 over a total of 12, because 8 and 4 is 12. All right. Maybe I've confused you enough with that. Let's go ahead and take a look at trapezoids. Okay, so we can see here a trapezoid, again, is a quadrilateral. That means it has 4 sides. It has exactly 1 pair of parallel sides. Okay, so when we look at either of these trapezoids here, I can see that this side is parallel to this side. Remember, we've talked about that parallel lines are lines that will never intersect. They never cross over. They're always the same distance apart. So we call these 2 parallel sides my bases. Okay, so that's why I have B1 written right here. This is base 1, and this is base 2. Now, again, I could call my bottom one base 1 and the top base 2. It doesn't really matter. So those are my 2 bases. Okay, and so they have 1 pair of parallel sides. Now, sometimes these sides right here can be congruent, meaning they have the same measurement. Sometimes they can have different measurements like this one does. It doesn't really matter, okay? If they have the same measurement, we call those isosceles trapezoids, because remember how we talked about isosceles triangles, how they have the same side measurements? Those sides are called congruent, or they're the same length. Same thing here. When I have a trapezoid, that the 2 sides of it that are not parallel, when those 2 sides are the same length, they're called congruent. So it's an isosceles trapezoid. All right, so let me erase a little bit and then we'll get going on our notes. So now lesson 85, going back to our notes about trapezoids. Okay, and it says a trapezoid is, and a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides. And it says to find the perimeter of a trapezoid, find the sum of the lengths of the 4 sides. Excuse me. So I have perimeter is equal to A plus B plus C plus D, where A, B, C, and D are my 4 sides. So for your next bullet point, it says write the formula for the perimeter of a trapezoid. P equals A plus B plus C plus D. And then it says to find the area of a trapezoid, find the product of the height and the mean of the lengths of the parallel sides. Well, that's a whole lot more confusing than it's going to be when we look at what the formula is. Okay, so the formula for the area of a trapezoid is going to be A is equal to 1/2 times base 1 plus base 2 times the height. Okay, so I have to add the length of my two bases together and multiply that by 1/2 and by the measurement of the height. So 1/2 times base 1 plus base 2 times the height. And then the next thing says if two non-parallel sides are congruent, the trapezoid is an isosceles trapezoid. So my last bullet point says if two non-parallel sides of a trapezoid are congruent, and I put in parentheses the same length, so the first blank will be length, then it is an isosceles trapezoid. So isosceles is that next blank. Okay. So now we've got our figure here. It tells us this figure is an isosceles trapezoid. I can see I've got sides. I've got A, B, C, D. And again, it doesn't matter which one I name what. I just know that when I find the perimeter, I add them all together. I know that this is one of my bases because it's one of my parallel lines, and this is one of my bases. So to find my area, I've got to add those two together and multiply times 1/2 times the height. Okay. Let's go ahead and take a look. So to find the perimeter, we had to add one side plus another side plus another plus another. Okay, so 1, 2, 3, 4. Now notice this right here is where they put the 4 and the 2 together. Okay, you could, they've got it separated as 4 and 2, or if you put it together as 6, same thing. So we're adding all of our sides together. So again, I can only combine like terms. So I've got 2 times the square root of 2 plus 2 times the square root of 2 is 4 times the square root of 2. And then 2 plus 6, or 2 plus 4 plus 2, 2 plus 6 is 8. So I write that as 8 plus 4 times the square root of 2 units. Then to find my area, remember area equals 1/2 times base 1 plus base 2 times the height. So they have the 1/2. They said one of my bases measures 2, the other base is 6. So I add those together and multiply by 2. So here I'm going to have 1/2 times 2 plus 6 is 8. And then my height is 2. So I've got 1/2 times 8 times 2. Half of 8 is 4, and 4 times 2 is 8. So I'm 8 units squared. Okay. So let's go ahead and take a look at this example over here. All right, it says list everything you know to be true about the diagram below, find the perimeter and the area. So what kind of figure is this? We know it's a trapezoid. A trapezoid is a type of parallelogram. Not a parallelogram. A trapezoid is a type of quadrilateral, and a quadrilateral is a type of polygon. Okay, so we know about its shape. We know that perimeter formula is side plus side plus side plus side. We know that the area is we take half of the two bases added together times the height. Okay, so that's what we're going to work on now. The first thing let's do is let's look at the perimeter. if I look at this side all together, notice this one's 6 and this one's 2. So the whole entire thing is 8. Okay, so I've got 8 plus 2 times the square root of 2 plus 2 plus 2 times the square root of 10. So the perimeter equals, this is where I start looking at like terms. The square root of 2 and the square root of 10 are not like terms. Only the square root of 2 can be added to the square root of 2. Only the square root of 10 could be added to the square root of 10. So since they are not the same, they cannot be combined, so they have to be left separated. What can be combined is 8 and 2. My numbers that are by themselves are the only ones that can be combined, and 8 plus 2 is 10. So we'll have 10 plus 2 times the square root of 2 plus 2 times the square root of 10. I wish this text didn't do problems like this. I wish they would just do normal problems with numbers that we can calculate. To me, it's more confusing. And so, but just know that I guess what their intent is to give you some practice here with dealing with radicals and understanding that you can only add them together when they are the same. Okay, so we'll just keep working with that and keep practicing with it. Okay, so there is my perimeter, and we're just going to call that units since it's not identified as a certain unit of measurement. All right, now we're looking at area. And again, we said area equals 1/2 times my bases added together times the height. Okay, so again, I like to go ahead and write my equation, so I make sure as I plug everything in, I know that 1/2 is part of my equation. That's nothing I'm substituting in, I just bring it down. Now look at my two bases. Again, I don't have to stress about which one's base 1 and base 2. All I know is that I need to add my two bases together. So I'm going to go ahead and say 2 plus 8 is in parentheses. And then my height, remember my height is going to be what intersects the base at a 90-degree angle. And so that is going to be 2. So now I have 1/2 times 2 plus 8 times 2. So 1/2 times 2 plus 8 is 10 times 2. Half of 10 is 5, and 5 times 2 is 10. So 10 units squared. How's everybody doing with that? You feel okay? Awesome. All right. Now we're going to look at this figure down here at the bottom. All right, so we see a trapezoid, but also notice that I could really look at this as one triangle here, one triangle here, and a square here. Okay, so if I wanted to, I could find my area of them separately and then put it all together, but we know that we've got a formula that makes it easier. So, but just recognize that a lot of times when we're looking at shapes, they can be made up of other types of shapes put together. Or just like we learned that, you know, with a triangle, that's half of a rectangle or half of a square, whatever. All right, so I went ahead and labeled this as much as I knew. If I saw that this measure up here was 3, then I know that this measure down here is 3, okay, because those are congruent. So that way, if this one is 3, this one is 3, and this one is 3, 3 plus 3 plus 3 is 9. So this whole measure right here is 9. So my entire base of my entire figure is 9. So one of my bases is 9, the other one is 3 at the top. Now I can look at my height. Again, my height is 3 because that is going to be from the base up to my top vertex. So I went ahead and labeled that with the letter H. So I can make sure that when I'm working with these formulas, I put everything in the correct place. Erase all this. Okay. So to find the perimeter, I'm going to have to add A plus B plus C plus D. I've identified, I went ahead and said, okay, I'll let A be 3 squared. I'm sorry, 3 times the square root of 2. I'll let B be 3. C is 3 times the square root of 2, and D is 9. So I'm going to add those together. So for my perimeter, I have 3 times the square root of 2 plus 3 times the square root of 2 plus 9. I combine my like terms. 3 times the square root of 2 plus 3 times the square root of 2. I can add those together, and that's going to be 6 times the square root of 2. Add the 3's together, keep the radical the same. And now I have 3 plus 9, so that would be plus 12. So I can either have it as 6 times the square root of 2 plus 12, or 12 plus 6 times the square root of 2. Either way, mark it units. Okay, now we're going to find the area, and we said area equals 1/2 base 1 plus base 2 times the height.
Right. When you combine the square roots, don't you take both square roots?
So since I'm adding them together, the square root stays the same. The only time I would take my square roots and put them together is if they are being multiplied. So when I add, my radical just stays the same. So it does not become the square root of 4.
Okay.
I only put them together if I multiply.
Yeah.
Okay. All right, so here we've got 1/2 times. We said this base up here is 3. This base down here is 9. And then we said our height is 3. So now I have 1/2 times 3 plus 9 times 3. So 1/2 times 3 plus 9 is 12 times 3. So again, this is the part where I say we can either multiply 3 times 12 and get 36 and take half of that, or I can go ahead and take half of 12. Half of 12 is 6, and 6 times 3 is 18. Either way, same answer. So I end up with 18 units squared. Okay. So that's with a trapezoid. Let's go ahead and turn the page to page 188. Let me erase this and we'll walk through it. Okay. All right, so it says to use the diagram of the trapezoidal lot to answer the following question. All measures are given in feet. So this is basically, we've got a lot, and we can see that you've got the grass and you've got the house and you've got the driveway. So they've given us some dimensions based on the lot and the grass and the driveway. Okay. So let me see something. Let's look at the information that they have given us. And where did I get that number for a minute? Trying to figure out why I had this number written down in my book. I want to make sure I didn't erase too much on my screen. Let me see real quick. Oh, okay. Now I see what I did. All right. So basically, when we're given this figure here, okay, they've told us that. Now, one of the things I want you to look at is, even though I've got my slanted at the top, this is actually a trapezoid, because notice, and I don't know if my screen's going to turn when I turn it. I'm trying to figure out how I could make it turn. Let's see. So basically what I'm going to do is I'm going to hold my book up for a minute. Okay. So when I look at it like this, it looks kind of funny, but what if I turn it like this? When I turn it like this, I can actually see now that it's going to be a trapezoid, because I see I have my top and bottom bases. I can see that those are my parallel lines. And then I've got my two sides, that one is slanted more than the other. The other one might not even be slanted at all, but this is actually a parallelogram. Okay. So I can see that if I were to turn it and shape it, I'll go ahead and draw kind of a, let's say that I turned it and it looked like this. Okay, so basically this is like if I were to rotate it and turn it, it would look like that. Is everybody good with that so far? So basically, if I were using that and I wanted to go ahead and look and just rotate those measurements, then this is the side that is 87 and a half. Let me change that color so it'll stand out a little bit more. This is the side that is 87. That is a half, or is that a fourth? Where are my glasses? Oh, they're on my head. Okay, yes, that is a fourth. 87 and a fourth. I can see that this side is the one that's 100 and a half. And then this side is 128 and 3/4. Okay, so basically all I did was turn it. So it helps me kind of see what that is. And you can see how I had the little dotted line drawn. So basically that's like my height right there. So my height is listed right there, but I know it's the same length as this one right here. So my height is the same. It's going to be 100 and a half. So now I can go ahead and look at, so all it asked for was find the area of the grass. So I'm finding the area of the green part. Well, notice that I'm going to have to find the total area of the entire shape. Then I'm going to have to find the area of the house and the area of the driveway and subtract those from the area of the entire shape. Okay, so the first thing I'm going to do is find the area of my total shape. So my area is going to be 1/2 times base 1 plus base 2 times the height. So let's take a look at that. Base 1. So we're going to have 1/2 times, I'm going to say 87 and a fourth. 87 and 1/4 plus 128 and 3/4. 128 and 3/4 times my height, which we said is the same as the measure of this side right here, because those are going to be the same. So 100 and a half. Okay. So now when I add these two together, remember adding fractions, numerator plus numerator, keep the denominator. So I'm going to have 1/2 times, let's see, 87 plus 128 is going to be 87 plus 128 is 215. And then 1/4 plus 3/4 is 4/4. Now, since 4/4 is equal to a half, then that means I'm going to put that with it. So I've got 1/2 times 216 times, not 1/2. What am I doing there? This needs to be 100.5. Oh my.
Jennifer.
Yes, dear.
It's actually 216. Like I did it on my calculator. I can't really see it very well because of the background, but it's 216.
Right. So that's what I was showing you is that 215 plus 4/4 is going to end up being, and then that 4/4, we put it as 216. That 4/4 is one whole that adds to the 215. So that makes it 216. And then this right here is supposed to be 100.5. So now 100.5. Now using a calculator, what we can do is we can put that in and say 1/2 times 216 times 100.5. And that's what we're going to do here. So we're going to have 216 times 100.5. So I'm going to have 1/2 of 21,708. And that is going to equal 10,854. And I think they said we're using feet, right? So 10,854 feet squared is my total area of my figure. Okay. So now I've got to find the area of my house. So let's go ahead and look at that. The area of my house, area equals base times height. So area equals 50 times 40. Area equals 5 times 4 is 20, and add my zeros. So that's going to be 2,000 feet squared. Now I've got to look at my driveway. My driveway is 20 by 25. So area equals 25 by 20. 25 times 2 is going to give me 50, and I add a 0 on the end. So that's going to be 500 feet squared. So all in all, my house and my driveway together are going to be 2,500 feet squared. So we said house and driveway equal 2,500 feet squared. So I'm going to need to take 10,854 and subtract 2,500. 4 minus 0 is 4, 5 minus 0 is 5, 8 minus 5 is 3, and 10 minus 2 is 8. So my area of the grass is 8,354 feet squared. Okay, so I just used my formula of my trapezoid. Now, if I wanted to, I could make it much more difficult, and y'all know I don't like to do that. I could have changed this and said this is a square and this is a triangle and all that good stuff, but we're not even bothering with that. We're just going to use our area of a trapezoid formula, okay? So let's review our measurements or our formulas real quick. Perimeter, I'm always just going to add the sides. Area of a rectangle will be base times height. Whether it's a rectangle, a square, whatever, I just multiply my two sides together, length and width, base and height, side squared. Triangle, area is 1/2 base times height. And then today we learned that the area of a trapezoid is 1/2 of my bases added together times the height. So similar to the triangle in that I've got 1/2 and I've got bases times height, but I have to actually add my two bases together this time. So that's what's the main difference between trapezoid and a triangle is with my bases, I have to add two bases together instead of just having one base like a triangle does. Okay. So let's go ahead and take a look back at our worksheets for a minute and let's see what we've got in those. All right, so worksheet 43. Worksheet 43 is perimeter and area of parallelograms. So again, we can see where they have this section about our figures and our drawings and our symbols. So you're going to use, you can look back at page 180 for that. Okay. Whoop, let me say, look back at, actually, you know what? Why did they give the exact same? This is exactly the same thing as 180. So you know what? Let's just delete this. That's crazy. All right, so omit that. We've already done that. There's no reason to do it again. I thought it was practicing with other numbers and not numbers, but other drawings and number letters and things like that. But it's exactly the same. There's no sense in doing that again. Okay, so let's look at activities 2. Find the perimeter and the area of each figure. So go ahead and put perimeter equals A plus B plus C plus D. You're going to add up your sides. And then area equals base times height. And remember, your base is going to be one of your longest sides. Your height goes from that vertex up, okay? And so in here, it tells you what each of the measurements are. So what I would want you to do is when you're looking at this one, you could go ahead and label everything. It says AB is 20. So what I'm going to do is I'm going to go up here and say from A to B is 20. B to C is 10. So that means this side is 10. H is 6. So if my slanted side here is 10, that means this side is 10. If my top line is 20, then the line that's parallel to it is also going to be 20. Okay, so I want you to label up your diagrams based on the numbers that they've given you, and then you're going to find the perimeter and the area of each of these figures. Okay, so that's activities 2 on page 143. Then on page 145, you're going to have activities 1 dealing with our different triangles. Notice we're looking at ABD. So that's going to be this one right here. Then my next one is BDC, that one right here. And then finally ABC, looking at the whole thing. Find the perimeter and the area. And then perimeter and area using a trapezoid. Okay, pay close attention. You may want to put a note that says only add like square roots. So if they're not the exact same, you're not going to add them. Let's go ahead and look at the area of this figure. Okay, we'll go ahead and do the area together. Area equals 1/2 base 1 plus base 2 times the height. So I'm going to have 1/2 times. Now, base 1 is 4 times the square root of 3. Base 2 is going to be this right here. So I've got 4 times the square root of 3 plus 12 times the square root of 3. Since they're both the square root of 3, they can be added together, and 4 plus 12 is 16. So I have 16 times the square root of 3. And then my height is 4 times the square root of 3. So 1/2 times 4 times the square root of 3 plus 16 times the square root of 3 is going to be 20 times the square root of 3 times 4 times the square root of 3. Now remember, we talked about when I multiply, I can now combine my radicals. So I've got 1/2 times, basically I've got 20 times 4. So that's going to be 80. And then I've got the square root of 3 times the square root of 3. So think about if I've got the square root of 3 times the square root of 3, those are my buddies that can come out, and they can come out as a whole number 3. So I've got 1/2 times 80 times 3. I'm going to bring this up here now. So now I've got half of 80 is 40 times 3 That's going to be 120, and our unit of measurement is yards squared. So for the area for that one, we did have to add our like radicals together, but when we multiplied, we were able to get rid of our radicals because the square root of 3 times the square root of 3 is the same as the square root of 9. Square root of 9 is just 3 times 3 together. That's my two buddies, and it comes out as the whole number 9. Okay. So that's going to be our homework, is going to be to do activities 1 of page 44. So we're doing activities 2 of worksheet 43. So let's see, today is 2-4. So I'll put homework 2-4. We've got worksheet 43, activities 2. And oh, my screen went off. Homework 2-4. Oh, my whole thing's going away. It's going to be worksheet 44, activities 1. Okay. Any questions on what we've got? Sorry, we've actually gone a minute over today. Sometimes we usually finish early. All righty, so finish those up for homework, practice on those area formulas. And if you have any questions, let me know. But if not, then I will see you guys on Monday. All right, I hope y'all have a great weekend.
Bye.
Bye-bye.